I want to find the derivative of y equals 3x plus 1 squared. So this is a problem that involves a chain rule. The first thing of the chain rule is to bring down the exponent. So we're going to bring out the 2 in front, keep the inside the same, subtract 1 in the exponent, and multiply by the derivative of the inside. So that's going to be 2 times the quantity 3x plus 1 to the first, and then the derivative of 3x plus 1 is just 3. So then 2 times 3 is going to be 6, and that's going to be 3x plus 1. We can distribute out the 6, the 3x, and 1 to get 18x plus 6. And that's the derivative. Y equals the square root of 13x squared minus 5x plus 8. I can rewrite this as a power of 1/2. So I don't like to use radicals whenever taking derivatives. I always want to change it into a parentheses and a fraction. So it's going to be 13x squared minus 5x plus 8. I want the exponent to go out in front. I'm going to subtract 1 in the exponent and then multiply by the derivative of the inside. So now the derivative, I have 1/2 times 13x squared minus 5x plus 8 to the 1/2, to the negative 1/2, because 1/2 minus 1 is negative 1/2. And then times, the derivative of 13x squared is 26x. The derivative of negative 5x is negative 5, and then 8 is 0. Now this 1/2, I'm going to distribute it to 26x and negative 5. So I'm going to pull that in front first. So 1/2 times 26x is 13x, and then 1/2 times 5 is negative 5/2. And then times 13x squared minus 5x plus 8 to the negative 1/2 power. And if we really want, we can move. So let's say we don't like the negative exponent. We can put it all in the bottom. So it could be like under square root 13x squared minus 5x plus 8. And that's the derivative. Y equals 1 minus 4x plus 7x to the 5th to the 30th power. So for the derivative, I'm going to bring down the exponent. So the 30 is going to come down. I'm going to subtract 1, and then I'm going to multiply by the derivative of the inside. So I have 30 times 1 minus 4x plus 7x to the 5th. And we're going to raise it to the 29th power times the derivative of 1 is 0. Derivative of negative 4x is negative 4. And then 7x to the 5th is 35x to the 4th. The 30 is going to distribute out to the negative 4 and the 35x to the 4th. So 30 times negative 4 is negative 120. And then 30 times 35 is 1050 x to the 4th. And we're going to multiply that by the quantity 1 minus 4x plus 7x to the 5th, all raised to the 29th power. And we don't have to simplify this any further. y equals quantity 4x plus x to the negative fifth raised to the 1/3 power. Using the chain rule, I'm going to bring the 1/3 out in front. I'm going to subtract 1 in the exponent and then multiply by the derivative of the inside. So this is 1/3 times the quantity 4x plus x to the negative fifth. 1/3 minus 1 is negative 2/3. The derivative of 4x is 4. Derivative of x to the negative fifth is negative 5x to the negative sixth. I'm going to bring this out in front so we can have it as 1/3 times 4 minus 5x to the negative sixth. And then because 4x plus x to the negative fifth has a negative exponent, that's going to go on the bottom. So that's going to be 4x plus x to the negative fifth. And now we're going to put it as a positive 2/3 exponent. We can finally combine this to just be 4 minus 5x to the negative sixth over 3 times the quantity 4x plus x to the negative fifth raised to the 2/3 power. Y is equal to 8x minus x to the sixth over x cubed, all raised to the negative 4/5 power. So this is a great chain rule problem. I'm going to bring down the exponent to negative 4/5, subtract 1 in the exponent, and then multiply by the derivative of the inside. So that's going to be negative 4/5 times the quantity 8x minus x to the sixth over x cubed. Negative 4/5 minus 1 is negative 9/5. The derivative of 8x minus x to the sixth over x cubed can be solved two different ways. So we can either use the quotient rule, or we can break this up into two fractions. I don't want to use a quotient rule because that's too much work and it's a little more complicated. So what I'm going to do is break up this fraction. So this is going to have common denominator of x cubed, and it's going to be 8x and x to the sixth. 8x over x cubed is 8 over x squared, and then x to the sixth over x cubed is just x cubed. So instead of taking the derivative of this thing, I can take the derivative of 8 over x squared minus x cubed. I'm going to take it a step further and rewrite x squared as x to the negative second power. And now taking the derivative, I'm going to bring down the exponent to get negative 16 x to the negative 3 minus 3 times x squared. And that's going to go in place of the derivative. Okay, next thing we can distribute out the negative 4/5. Well, I guess we can distribute out the negative 4 first. So negative 4 will go to negative 16 x to the negative third and negative 3x squared. And then we're going to flip the fraction so we don't have a negative anymore. Okay, so negative 4 times negative 16 is 64 x to the negative third, and negative 4 times negative 3 is 12, so that's 12x squared. Okay, and that's going to be all over 5. we're going to flip the fraction, so it's going to be x cubed over 8x minus x to the 6th. And that's going to be raised to 9/5 power. And at this point, this should be good enough, so we don't need to simplify it any further.